solving quadratics is what we're starting today. Now, here's some things, go ahead, Mr. Austin, here's some things that I need you to know. First off, there are 4, I think, I'll name them all in just a second, but there are 4 different methods that we'll learn to solve a quadratic. Today's method is by graphing. After I do it by graphing today, I'll never do it that way again. Reasons. Why do you think I might not ever do it graphing again? What do you think? What's a guess? You might not know, just guess. Why might graphing be the least useful of the 4 methods we learn? What happens? No. What happens if they didn't get their spaces exactly the same distance? Right. So human error, not getting your spaces right, drawing your graph, that could mess it up, right? So that's why I'm not as accurate like Aaron said. That's why I won't do it anymore after today. Okay. Now here's what we need to know about. Let me get my marker to write on that. What we need to know about that. When you're told, and this problem didn't tell you to solve, you didn't know that's what we were doing, but when you're told to solve, there are several different words that can be used. So this thing gets off Thanksgiving break, we'll roll. Come on, you worked this morning when I wrote the problem up there.
It should take like 5 minutes. I don't know if this is
There we go. Alright, so when we're told to solve, we could be finding solutions. These are all different words you need to be familiar with. We could be finding zeros. We could be finding roots. All of that. If you see something that says find the roots, that means solve it. If you see something that says find the zeros, that means solve it. Obviously, solutions means solve it. Now, intercepts, these are different words for solving. Intercepts also means to solve. All those things mean the same thing. Now, I'll erase this here in just a second, but I want to draw it up here because I want to show you the different options that you have. If we had, bless you, and we're quadratics, that's all we're doing. This, last unit we did absolute value, quadratics, and lines. This is just quadratics, that's it. So if we have a quadratic, which would be a parabola, that looks like that, this would have 2 solutions. See where I put those dots? Those are the solutions to your quadratic, where it crosses the x-axis. So something like that would have 2 solutions. I could look something like that. We're going to pretend I hit it. And have 1 solution. Just the vertex touches. That has 1 solution. I could also have no real solutions, because I could go like this down here and never cross the x-axis. So that would have no real solution. And notice I emphasize real, because we're going to learn about imaginary numbers this unit. Bells mean anything to you? It's like 6 minutes after the bell rings. Well, that's enough to be absent. You might want to consider that. So we never cross the x-axis. We got no real solution, and I emphasize real because we're going to learn imaginary numbers this unit. It's craziness. Okay? So there's all the options. Our quadratics could have 1 solution because they have their vertex hits the x-axis. Our quadratic could have 2 solutions because it crosses 2 times, or it could have no real solutions because it never crosses. So looking around at the graphs that y'all did on the board, I'm expecting this one to have 2 solutions, right? The graphs y'all drew on the board show it crossing the x-axis twice, right? So let's go up here and look at it and see how you did on your graph. And get that cleared out. Now, Riley was talking about standard form stuff a second ago. This equation I gave to you was in standard form. So your options, you could have just typed in the calculator and went to the table, and that would work. I see over there they use the negative b over 2a shortcut, so that's what I'm going to do real quick. So I would have negative 2 over 2 times 1, which gets me negative 1. So then I plug that negative 1 back in, because that's the x of my vertex, that's my axis of symmetry, so it's going to be somewhere over here, right? I plug that back in, negative 1 squared plus 2 times negative 1 minus 3. So it's 1 minus 2 minus 3. So 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So I have a vertex at negative 1, negative 4. And that looks like what y'all have all got, so that's pretty good stuff. So I'm going to go left 1, erase those little things I didn't circle a second ago, and down 4. 1, 2, 3, 4. Okay. So now, if we're thinking about our table, and again, you could have got this off your calculator. If that's my vertex, that's going to be in the middle. So I need to pick a couple on the right side, so I might go 0, 1. A couple on the left side, so negative 2, negative 3. Okay. Anybody see, Jalen, are those off your calculator that you got over there?
Yeah.
Okay, so I'm going to just speed us up and use the table that Jalen wrote on the board. Negative 3, she got 0. Negative 2, she got negative 3. Negative 1, I've got 0, she got negative 3, and 1, she got 0. Okay, now before I even draw that graph, I know my answers. Do you know how I know them? Okay, think about what I told you a second ago.
Oh, that's too.
If I am where I cross the x-axis, means I didn't go up or down any, so the y value has to be at 0. So if you went ahead and plotted those, let's see, right 1 up 0, over 0 down 3. Already got that one. 2, 1, 2, 3, and then negative 3, 0. So this time, because the calculator, because it came out on nice whole numbers and we saw it in our table, we didn't have a human error element enough here. So that point where that crossed the x-axis is negative 3, 0. This point where it crossed the x-axis is 1, 0. So those are the two solutions to that quadratic. Now, what is the y coordinate going to always be every time you're told to solve a quadratic? Okay, that tells me you don't know what a solution is because we just went over it. Solution is where we cross the x-axis, true? We talked about that? So solution is where we cross the x-axis. So what's the y coordinate going to be in every solution?
0.
0. Okay, so you're not going to have to write that every time. Now you're just going to be able to write x equals negative 3 and 1. Because you know those would both go with a 0. Good stuff, good stuff.
Can you scroll up there,
You
Coach?
bet your boots. Needs to see that equation up there.
Wait, what'd you say about the y and a what?
She said it's always gonna be 0, so you wouldn't need to know that. So you just put x equals
So on
negative 3.
every solution,
One.
is either the y.
Yeah.
Yes,
All of them.
because the solution means where it crosses the x-axis.
Right.
Very good, very good. Good explaining there, Ariana. I like it.
Thank you.
Yeah, let me let
Okay.
Austin, he wanted me to go up. You ready, Austin?
Yep.
Alright, let me go back down now with some of them. Hey, 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 hey. So. Alright. Let me erase all of that so I can leave that problem for next period. Oh shoot, that was bad. I just got out of control there. X squared plus 2x minus 3. Okay. So, white background. Come on. Get the piece of graph paper. Alright, so let's say we had f of x equals negative x squared minus 10x minus 25. So today, the only way we know how is graphing. We'll learn other ways, but while I'm thinking about it, graphing, taking square roots, factoring, completing the square, quadratic formula. So there's 5 ways. I forgot about one of them. Yes, minus 25. So we'll learn 5 ways altogether. When we get them all 5 learned, you can do whichever one you want. But today it's graphing. So right now you need to be started on graphing that, either in your calculator, grab your calculator if you want it, or do the, like I did, do the negative b over 2a deal.
Mine ain't graphing.
10x. Why are you sorry? You just made a mistake. It's okay. This is an interesting one. I just looked at Kinley's calculator.
If you got a negative x, but you have like its fx equals negative, would it turn that into a positive when you plug it in to find your y over 10?
Negative b over 2a. I think this would stay negative, wouldn't it?
Yeah, it is negative.
Okay.
I was saying when you plugged it
Oh.
into the negative x,
So you
would
would.
it make it a positive 5 instead of a negative 5? Since that's a negative. And 2 negatives make a positive.
So you're now plugging it in. I
Yeah.
just want to make sure I'm not plugging it wrong here. Okay, you would do negative 5 squared, which makes it a positive, but then you have to make it a negative again.
Negative 5.
I'm sorry, I wasn't following you. Yes.
It looks a little weird because I looked out, it was 25, I just counted the 5.
That's fine. You got an answer? X equals what is your answer? Alright, how'd your graph do? Do I got something that looks similar to what you had on your graph? I mean, I just kind of threw it up there real quick, but general characteristics look pretty good. So how many solutions does this one have? Just one. Just hits the vertex there. So when Kinley was finding the vertex a second ago, she actually was finding her answer, wasn't she?
Yeah.
Very good. So just be.
It just be x
Keep going. Negative
X,
5.
yes,
ma'am. That's it. Nothing to it. How could you do that real fast in the graphing calculator? What would you be looking for?
The graph in front of 0?
Wherever the 0 is in the y, right?
So on the chart, right?
Go to the table, look for where 0 is in the y.
So if this is 0, that means it's the.
Yep.
Do we even have to graph it? If we just use it?
You could just use the calculator. I don't have a problem with that. I do not. Okay.
Wait a minute.
Okay, I'm not rushing you. Is anybody having problems yet? This doesn't get any harder today. This is where we are. Is everybody all right? Alrighty. See what cracking. Looking good. Looking good, looking good in the hood.
Is it always gonna be a negative x squared, or is there ever gonna be a number somewhere?
Yeah, I'll give you one with a number next. Good thinking. Alright, let's see if we can solve this one by graphing. I'm gonna get my white paper. Oops, oh, there we go. Okay, come on, graph paper, show up for me, thank you. Alright, so Riley asked about a number in front of the x squared, because the first one we did was just 1x squared, and then that second one was negative 1x squared. So let's look at something other than 1. There you go. See what you can figure out on that one. 2x squared plus 6x. So if you're thinking standard form, it's missing a c, but that doesn't matter to how you're going to graph it, either in your calculator or do the vertex formula.
If it's 0 and 0, that would look. Like, how do you know which one is the answer?
Well, remember all the different options, it can have 2. So if there's 2, you would have to put them both.
This doesn't make any sense.
I'm sorry.
No, I'm just confused. Would that be right?
Negative b over 2, yes.
But negative 6 divided by 4 is
Yeah.
which one do you want?
Whichever one you want.
Oh.
You get your summer mail?
It is 1.
Okay, I think I got it.
Okay, I just copied those off of the table on Riley's calculator. So,
I think I did something wrong.
hold on just a second, I'll come look.
Because I mean, that.
No, that's, yes it can. You start looking for where stuff repeats. You got -4, -4. That was at -2 and -1. So the lowest point would have to be halfway between those, and halfway between those is your -1.5. So it just didn't give you the vertex here because it was a decimal. But see, if it's going, if you start graphing that, and you went left 3 and up 0, left 2, down 4, and then left 1, down 4, it has to turn, because it can't just go straight across the -4, right? So the turn would be between those two, which is that. Okay, so like Jalen asked a second ago, I got my answers just by looking at Riley's table. Right?
Right.
So, everybody good on that? Now, when would, since Kelly ran into this on the vertex, she found the vertex that's -1.5, -4.5?
That's what I
Good, 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 good. So when would the table, when would I need to do more work, maybe, is what I'm asking. What if that had not been a whole number, -3? Could it ever cross on not a whole number? No. So, my parabola, just plot these, crosses at 0, 0, and -3, 0. So it's something that looks similar to that. What if it crossed right here? Would that show up on my calculator?
It would.
Our calculators default to just those whole numbers.
Oh, okay.
So that's why we're gonna learn other methods.
Okay.
Okay, everybody all right with that? All right, do you wanna do another one, or you feel all right, or I wanna do what you wanna do.
I feel good.
Anybody not get -3 and 0 on that one? Everybody good? Okay, so the next method that we're gonna cover, and I told you that I named 5 of them, the next method that we're gonna cover is factoring. Factoring, something that you learn in Algebra 1, but it's not just gonna be you. Every Algebra 2 class every year forgets how to factor. And especially since y'all were virtual for part of your Algebra 1 class, it's gonna be, giving me a headache already thinking about it. So tomorrow we're gonna review factoring. Because then factoring is one of the easiest ways to solve. So we'll get that.
All right.
Everybody all right?
Yeah.
Woo woo! Everybody else say yeah.
Yeah. Go.